Hi everybody, today I'm going to teach you about exponential notation for powers of 10. Today your learning target is that you can represent and rename powers of 10 and demonstrate that you understand that each place value space is 10 times greater than the place value to its right and 1/10 of the place value to its left. So basically what you need to understand is that each time you move over one place value to the right, it's 10 times bigger. And when you move over one place value to the left, it's 10 times smaller. I bet you remember this guy from yesterday. He reminds us that exponents are big and beefy. They're big and beefy because the exponent tells us how many times we multiply the base. So, for example, 7 to the third power is not 7 times 3. Nope, that's not it. 7 to the third power is big and beefy. This is wimpy. 7 to the third power, big and beefy. So it's 7 times 7 times 7. Woo, big. 7 times 7 is 49. And then we have to multiply 49 times 7. Woo, 49 times 7 is 343. That's big and beefy. Now let's start applying the same idea to powers of 10. Powers of 10 are simply how many times we multiply together 10. 10 times 10 or 10 times 10 times 10, things like that. So we can start off thinking about 10 times 10. Well, we know here that our base is 10, and then the number of times that we multiply it together, 10 times 10, well, that was 2. So this is 10 to the power of 2. Well, let's think about this. We know that 10 times 10 is 100. Every time we see a 0 in here, we have a 0 down here because 10 represents one place value and another 10 represents another place value. So we have one place value, two place values. So now let's think about the number 1,000. 1,000 has 3 zeros. 1, 2, 3. That means that we're moving 3 place values. Every time we move a place value, we're really multiplying by 10. So 1,000 is the same thing as 10 times 10 times 10. Think about it. If you have 10 times 10, we have 100. 100 times 10, 10 100ths is equal to 1,000. So 10 times 10 times 10 using exponential notation is 10 to the third power. Let's think about how many zeros we need to write the number 1 trillion. It's a really big number. I'm going to start by writing the number. Remember, each group of numbers, so we separate the numbers by commas, right, to make it a little bit easier to read. But each group of these numbers, here, and here, and here, those are called periods. So this one is the hundreds. And it's marked by the ones, tens, hundreds. This one here is the thousands. And it's marked by the thousands, the 10,000s, and the 100,000s. Next one, millions. Marked by the millions, 10 millions, 100 millions. And then, of course, we go into the billions. Pattern here, billions, 10 billions, 100 billions. And then we're going to move our last place value to write the number 1 trillion, and this is the trillions place. So altogether, we needed 3, 6, 9, 12 zeros. That was a whole lot of zeros. So instead of writing out all those zeros and having to think about all those different place values as we're writing that number out, we can write in a special way using exponential notation. So let me start by writing out the number 1 trillion with our 12 zeros. 12 zeros also means 12 place values, right? We remember that our decimal point would sit right there. So every time we are moving over, multiplying by 10, we're moving over 1 place value to the left, and it's a power of 10. So 10 times 10, remember, was 100, and that was 10 to the power of 2. 10 times 10 times 10 was equal to 1,000, and that was 10 to the power of 3. Well, this time, we're going much, much bigger. We have 1 trillion. So, we have 12 place values. So, I don't know if I even really left enough room. I'm going to have to write kind of small. 10 times 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 10. Wow, that was a lot. So how many times did we multiply together 10 times 10 times 10? We did that 10 to the 12th power. Notice 10 to the 12th power, we also have 12 zeros. So this really is telling us how many place values we're moving. Now how about the number 10,000? How could we write that into exponential notation? We have 10,000. So I count here 1, 2, 3, 4 zeros. So that will be 10 to the 4th power, or 10 times 10 times 10 times 10. Okay, and just in case you don't really believe me, let's multiply 10 times 10. That's equal to 100. 100 times 10 is equal to 1,000. And 1,000 times 10, think about that. That's going to equal 10,000. 1,000 10 times. Now, before you go thinking that the number of zeros is the same thing as the exponent, let's think for a second about place value. So I wrote the number 1 and I put a decimal point and a whole bunch of zeros because we know that zeros that are behind the decimal point don't actually change the value of the number. So let's think back to the number 10,000. And we knew that that was 10 times 10 times 10 times 10 times 10, which was the same thing as 10 to the 5th power. Okay, so we can take this decimal point, and every time we multiply by 10, it's going to move the decimal point over. Watch. 1 times 10 is 10. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. So what we actually did here was move the decimal point over 1, 2, 3, 4, 5 places. 5, and we moved it over 5 places. Now I've got some for you to try on your own. I want you to write these in exponential notation. The first one is 100,000. The second one, 10 million. And the last one, 10 billion. These are the same numbers that you'll need to write in exponential notation for the Edmodo quiz to get ready for tomorrow. Thanks for watching. Have a great night, and I'll see you tomorrow.